Internationally known geologist Richard Munroe has said global warming is a toboggan ride we can't get off. So, is it all said and done? Are we doomed to global warming? I'm Dr. Brian McDonough. It's going to be a bumpy ride, but please join me on the Dr. Brian McDonough Show as we talk about global warming and its association with water, ice, glaciers, and volcanoes. There's much more than just gasoline and electricity involved here.
We just finished back in August. There was an event that took place. There's a sub glacier just off of called Suicide Glacier, just off the main McDonough Glacier. And that's been eroding. They have pictures of it from 1893, and basically it's a nice big glacier sitting there. And now it's basically you take a look at the photography. Now you have a lake in front of where the glacier was. That thing breached and flooded out a whole bunch of McDonough River and took a couple of houses with it, and it was a big event that took place. But that wouldn't have happened without the onset of global warming, because you can sort of see the McDonough is getting thinner and thinner, just like all the other glaciers in the world. And this is a global thing. Like when I just came back from Mongolia, worked there for 10 years or so in the early 2000s. Went to the mountains, thought, where did all glaciers go? Well, they're gone, right? And so it's a high inland plateau, and there's not a lot of moisture over there to build that in. So it doesn't get a lot of snow, it doesn't get a lot of precipitation. So eventually it'll cool down again, and the glaciers will come back. And then when I worked in the Arctic, when I worked in the Greenland, when I worked in Chile, I mean, all these places I've been looking at glaciers for 40 years. And northern Canada, I mean, it just things are gone. You know, like I worked at a radar station in the mid 70s on Baffin Island, and we could see Nudlik Fjord and the glaciers across there. And I was up there in 2010, and gone. It's all gone. I mean, just
So when you look at that, Richard, when you look at those things, and obviously there is the cycle of the planet, with us being here doing what we're doing, would those things still be there or would they be gone anyway? Like,
they'd be gone. They'd be gone anyway, but maybe not as fast. Everything combines on top of sort of like loading on, like you push and you put this factor, that factor, and things happen. We're seeing the effects all the way across. I mean, Europe is suffering because the Alps are losing their glacial cover. So all the rivers that feed Europe, the Rhine, etc., they're running out of water. So give them the 2100 is sort of the key point where the glaciers are gone, so the rivers will run dry. So all the transportation things they've got for all the shipping and everything, and all their boats, etc., go up and down the river. Well, it's going to be dry. So that's going to be a game changer. So how do you fix that? Well, you go to electric vehicles or gas vehicles or whatever, and that's going to put more stuff in the air. You got China that's got a billion people. You got India that have a billion people. They haven't had their industrial revolution yet. They still have to come to play. And so all the coal. I mean, there's so many factors that are out there that we just can't control.
so when we look at this, and I think a lot of people that I talk to are worrying about, let's say, their children, their grandchildren, saying, "Oh my gosh, what have we done to the environment?" It's a combination. There's the natural things that are happening, and then we're sounds like we're precipitating these. We're making it happen faster. Whatever we're doing, we're making it happen faster than it would have. Are we looking at dramatic changes in 1, 2 generations, or are we looking at something that's 3,000 years off?
No, we're going to start seeing it. It's here now. I mean, take a look at the last hurricane that basically went through Florida, and the one that slammed into California. They've never had the typhoons like that going through, filled up all the reservoirs and stuff. But it affects a lot of things, and the stuff we don't see, like it's the old saying of, if a tree falls in the forest and no one's around, does it make a noise? That's sort of the big perplexing question. Well, we're seeing this in the Arctic. When I was working in Siberia, all the permafrost that's up there. When you go up to northern Canada and you go helicopter or plane or walking or snowshoe, whatever you're doing up there, you see just how expansive these terrains are, and they're warming up, and so you get these penguins that are forming, these ice wedges that are popping up, and so the permafrost is thawing out, and what that does is release a whole bunch of methane into the atmosphere. So once you've gone through that cycle, and they'll throw methane into the atmosphere again, that changes the chemistry of the atmosphere, and that's something we can't stop, because as the world heats up, more methane goes in, and we get more global warming. It's a toboggan ride we can't stop.
If you find this interview with Richard Munroe interesting and you're learning quite a bit, make sure you take time to like the video and also subscribe. There's plenty more where this came from.
Pretty well, yeah. We're in an interglacial period right now. The standard glacial rune period is about 20,000 years. So we're like we got out of the last one about 12,000 years or so ago. So we got about 8,000 years, and we'll be back into another ice age, or glacial event. It depends on who you talk to, because an ice age is like a much bigger event, snowball Earth kind of thing. So it's all semantics, but it's not a straight line. It's not like you're coming into a landing at a runway where you sort of just drop right in. It's fits and starts and different things that are happening, because there's more than one uh, event that will actually accelerate and push through. So our timeline is basically about 8,000 years from now. But there's things that affect the um, the climate of the Earth, and I'm just going to talk about a few of the things that are sort of the bigger picture ones. One of them is volcanoes. People talk about that. That's a big ticket item. But if you look at the big one that we're waiting for, that's supposed to pop in about 200,000 years or so, and that's Yellowstone ago. That's a massive super volcano, and that's basically going to put ash all the way across North America, right into Mexico, and bury most of the United States. So that's something to look forward to. But that's about somewhere around 200,000 years is our timeline, we figure. We've had events recently that are causing some of the pain that we're seeing around the world. And one of them was the Hungatonga volcano that went off in January 2022 out in the South Pacific. And basically, that was just a massive, massive event. And Tonga, the island itself, basically disappeared. And it took with it about 150 meters of depth of water below it, and went straight up. And so we figure the calculations is somewhere around 145 metric megatons of water vaporized and went up. And so when you look at the Google or the YouTube videos of this mushroom cloud going up into the stratosphere, it was massive. Just an amazing amount of energy that sort of came out of it. So it's a massive volcano, but the ones that we have on our record that we know have affected our atmosphere, like in 1991, Pinatubo in the Philippines, and then in 1887, Krakatoa out of the Jakarta area. Both of those are big ones that have come over, and they certainly affected our Earth and gave us that nuclear winter over top with all the ash, and it basically cools the Earth down. But what happened with Hungatonga is, because it was mostly water that went into the surface or into the atmosphere, and it went so high, basically it had a reverse effect. And so instead of being like the nuclear winter where you cool the Earth, because it put so much water vapor into the atmosphere, it actually is increasing the temperature, acting like a thermal blanket. And so, these volcanoes, they're big triggers, and every time one pops someplace, it adds to the equation. And so the whole idea is to try to keep global warming down to a dull roar, and we set the target in the Paris Accords to try to go to about 1.5 degrees centigrade. Well, we're going to go over that. There's no way we're going to stop that, and certainly The volcanoes aren't helping, and everything else is going along. We're trying as a humanity to try to keep our world alive. If we go over the 1.5, it's not a point of no return, but it's a factor. We're looking at it, and so we could just look from historical records from the ice cores within Greenland and Antarctica. We could sort of see what's happened over time. So every fraction of a degree that we can get, back down or below 1.5 is better, and that's what we're looking for.
But let's say there were no people, we weren't here, and the Earth was just cranking along the way it is. Would global warming naturally occur without us? I mean, you mentioned how volcanoes can contribute and those sorts of things. Is there a natural cycle where it goes up and down and up and down?
Yes, there is. It's a cycle. There's a periodicity to it, and we have the smaller ones are 20,000 years. Then the next cycle would be 40,000 years, and then you're looking at about 100,000 years for some really big ones. And every, let's just say 700,000 years or so, we have a thing called snowball Earth, where the whole thing glosses over. And that's because of the natural changes we're having, the eccentricity of our orbit. We have terms called Milankovitch cycles. It was all figured out by hand by Milankovitch back in the 30s as far as what's happening with the rotation of the Earth around the sun. It's not like a nice, even, smooth. It wobbles around like a drunken sailor going around the sun. And so these little changes, a degree here, a degree there, makes a big difference. And then the rate of spin of the Earth. There's another factor we just came up that we found out that the moon is trying to escape. So it's leaving us about 3 centimeters a year, getting further and further away from Earth. So add another 100,000 years, and it's gonna change it. So instead of a 24-hour day, we'll have a 25-hour day. So little things like that change. But because the moon has such a big impact on our oceans, it changes the tides and does things. So it's all the combination of little things that all pop in there. Solar flaring, progression, different things that are all happening. And so whether the humans are there or not, the cycles will happen. We see them in our millennia, in all of our drilling and all of our records that we can be able to find. We see the spiking, and the key is basically CO2. So that's one of the metrics that we use. And so when the CO2 goes up, that's an onset trigger, and then we get colder after that. So we also have another thing called isostatic rebound. When the last ice age was here, we had about 2 miles of ice that buried North America, Canada, basically, and depressed the crust. Even though the crust is 20 miles thick, it pushed it down and about 800, 900 feet. And so it's starting to come out through like taking a dent out of the hood of your car. And so it slowly comes up a couple of centimeters a year. So Hudson's Bay, which is a great big inland sea, right in the center of North America, right in Canada. And that's slowly getting smaller and smaller because it's coming out like a dent. And so in about 8,000 years, Hudson's Bay is going to be dry, and because that dent's going to come out, so you're just going to have this great big permafrost plain, or this big plain going right across from ocean to ocean.
Now let's talk about people. And maybe we start in 1900, for instance. We have an industrial revolution, automobiles, all these things start happening. The world gets into the game. India, China, other people are now more developed. Things are happening. It seems to me in the last 5-10 years, it seems the weather patterns are quite different. Yeah, where I live in northeastern part of the country outside of Philadelphia, we would have snowstorms and cold winters, and we would have moderate degree of heat depending on the summer, and sometimes it'll be hotter than others. But it seems recently there's warmer winters, there's summers that are hotter, and we're having, at least in my area, tornadoes when we never had tornadoes. There's more hurricanes. Is this an impact of humans, or is it what the Earth is naturally doing? I think that's the primary question to start with.
I think a little bit of both. We put chemistry in the air. That's our biggest problem, and we did a good job of stopping the. We were killing the ozone layer, which would have fried us all. So they got the fluorocarbons out of the system, so that closed up the ozone hole, which is a good thing. But we certainly put a lot of pollution in the air. But it's the chemistry that's causing us the biggest problem with the chemicals that go up, because that acts as this big chemical soup at higher altitudes within the atmosphere. And you get different things happening, 50 miles up to 30 miles up, and it plays funny up top. And so the sunlight comes through and it activates certain chemistry. So these things are all taking place. Like when Hunga Tonga went off, basically what happened, all that moisture, all that water that went up in the vapor, that comes down with the sulfur particles and you make sulfuric acid. So we're raining sulfuric acid all the time. So that's going to affect things as well. And so the chemistry that's in there, when you have basically a live chemistry taking place at elevation, there's things that are happening above us, and there's not really much we can do about it, because those chemicals will stay in the air for decades. So we just have to pay attention to what we're doing to ourselves.
So when we look at the Paris Accords, let's say, and decisions are made to try to help, it can make a difference, a subtle difference, a great difference. Is there a way to predict what it's doing?
Well, the whole idea is to keep that 1.5. That's sort of a magic number, because we're trying to keep it on an even keel and keep ourselves from entering an ice age faster than the 5 to 8,000 years. You have to remember, we also had that mini ice age, a cold spell in Europe in the 1400s and stuff, where England was freezing and stuff, and that was like a little dip that took place, and then it got warm again, and then you just have to look at the historical cycles, and the history will tell you what's going to happen next. So if you go back about 8,000 years or so ago, and you go to Egypt, for example, they were farming cattle. They had all sorts of things taking place in the agricultural belt, and the Sahara was a nice place. And then over the last 10,000 years, what happened is it got warmer and warmer. And now you have the Sahara Desert, and so there's a global changes. So just watching that spread take place, and the movement of cattle and agriculture and livestock as it drifts further and further into the mid latitudes of Africa, that gives you a clue as to what's taking place, and that's all natural. Once again, it's all cycles, and it's not just one factor. You have to look at many different aspects to come up with a plan of what's taking place.
What should we be doing right now if we really want to do what we can to help future generations as well as ourselves? Is there anything we can do? And if there is, what should we be doing?
Well, what we should be doing is watching what we're doing with moving the water equation. It's called a Q when we're doing hydrology, and what you want to figure out where everything is stationary right now, because with moving the water around, that's causing some problems. We're losing ice on our ice sheets, with from Greenland, and gigatons of water a year. Same thing with Antarctica, and it's thinning. Say, like we talked about the McDonough, it's getting thinner and thinner, all these ice sheets. And what that does is put more fresh water into the oceans. So we're getting a change in our salinity. We're getting a change in the chemistry of our seawater, and also the temperature of our seawater. So if you take a look at some of the heat envelopes that are happening in Southeast Asia and Australia and the Pacific, that's causing a problem as well, because these heat envelopes affect the hurricanes and the strengths and where they're coming from. So it's all a combination. So watching the water is our main thing, because fish live in the water and we're running out of fish. If there's a metric out there, it's called how many fish in the sea. Well, we used to have it so that we had massive schools of cod and different things off the Grand Banks. And with overfishing and taking out the atolls and stuff and illegal fishing, we've shot ourselves in the foot. So we're running out of fish. Well, you run out of fish, the predators are running out of stuff, and then it goes all through the food chain. But water is what our main thing is. So we have to watch what's going into the water, what water we're taking out. And desalination is something that we're going to have to start to work with. That's the only thing that's going to keep us alive. Start building desalination plants and using and cleaning up some of the seawater we're taking out, rather than taking out of the groundwater reservoirs, because we're changing the tilt of the planet.
Wow.
There's 25 countries right now are using 80% of the water supplies each year. That's unsustainable. And so we're running out of potable water, especially like when I was in the Persian Gulf, working in there, Oman, in that whole Saudi area, it's hot and it's dry, and they need water. So they're doing more desalination just to be able to survive. But basically, we should be planting trees. That's one thing that we really need to be able to do, because trees also act as a barrier to the wind, and so it slows the wind down a bit. So if you can get some decent winds in there on the boreal forest and grow more trees, that can't hurt, because that takes out more of the CO2. So planting trees and watching the waters is what we really want to be able to take a look at.
This is Dr. Brian McDonough, and thanks for joining me and my guest, Richard Munroe, on the Dr. Brian McDonough Show. If you like this interview, please like it and subscribe, but also take time to see some other interesting videos, such as Johnny Carson, his life behind the curtain, or Paul Westhead, a legendary Lakers coach, subject of the HBO show Winning Time, his true story about what happened with the Lakers in 1980. Thanks again for watching.